The first example I want to share is essentially around a rideshare company. So in this example, you can see a rideshare company host core parts of their web application in Google Cloud. And imagine booking a ride where you're on a mobile app and the core mobile application being served from Google Cloud. And they've deployed their enterprise agents across various parts of GCP where they've got the core web application deployed. You can see also in the table view, latency that's going from different parts of Google Cloud into Ashburn, where they have a core payment service that's still on-premise. And this payment service is critical to ensuring that payments are made seamlessly across the Google core mobile app. And depending upon which region of the Google Cloud you're serving this content from, the payment service can be anywhere from 274 milliseconds all the way down to single millisecond. What's also interesting is when you look at the path visualization, we can see their connectivity from Google Cloud all the way to their on-premise payment service. We can actually sort the agents by network and location, different parts of the Google environment where the agents are hosted. So we can see agents in the Omaha, Sao Paulo region, Belgium, Australia, Japan, etc., that are all connecting to this payment service within the on-premise network. The other really interesting point I want to share is being able to see these red links that are going across a link local address, which belongs to a cloud router that connects to their on-premise network. And if we zoom into this agent environment, we can actually see in the agent details the presence of essentially a VPN tunnel through the TCP maximum segment size of the path MTU being smaller than what you typically expect. A typical packet with no VPN tunnels present would have a path MTU of 1500 bytes and TCP maximum segment size of 1460 bytes. And so you're seeing the presence of a tunnel, and the red links are effectively showing you links with high latency that are connecting from the South America East 1 region to this link local address. And eventually, they connect you through this address within the rideshare's own network, and then through their private network on down to the payment service that's being accessed. Now, what's interesting is they see an increase in payment verification failures through their core web application. And when that happens, they're able to very quickly go to that time period and see where the core web applications are failing, and then being able to visualize where the problems are occurring across Google Cloud, the partner interconnect that's connecting them through to the on-premise data center, and then the on-prem network that's serving the payment gateways. And during the time of high loss events, when the payment failures happen, you can see on the left-hand side that most of that loss is coming through two specific GCP regions in the United Kingdom, as well as Sao Paulo, Brazil. While all the other GCP regions across Singapore and others are seeing zero loss because of the green color on the agents. And if we simply focus on this particular set of agents and hide all other agents as part of this network, we can now see where the loss specifically is coming from. As we saw earlier, this particular US region in Europe, GCP region in Europe, is connecting through a link local address that connects them through the rideshare's on-prem network or partner interconnect, then connects them through the partner interconnect, and then is now seeing loss, a high amounts of loss, across the last link that connects them to the payment infrastructure. And the broader point here being, as companies continue to migrate to the cloud, it's a longer migration across multi-year that requires parts of their web application stack or application stack to be hosted in the cloud, while others are still hosted on-prem. And being able to understand how the cloud network, the partner interconnect, or even internet VPNs, and then on-prem infrastructure are impacting end-to-end experience for users is critical to understanding your overall cloud performance.